The first step in the engineering design cycle is to ask or determine what problems our group is trying to solve. We knew we wanted to build a bubble blowing machine, but we didn't quite know where to start. We decided to ask ourselves a few questions. What did we want the theme of our project to be? What were our goals for the functionality of the machine? And what were the aspects we wanted to incorporate into our design? In order to answer these questions, we needed to do some research. Our research consisted of mainly looking at existing patents for other bubble machines. In the patents that we looked at, we saw a pattern of boxes with fans inside them that blew focused air at a rotating wheel of bubble wands, so we thought we'd take a crack at replicating that design. Each of the patents had a different fan though, so at first we decided to use a fan like the patent in the middle, with only a few big blades, as a fan like that would be easier to come by. We decided to use an Arduino microcontroller to adjust the speed of our rotating wheel. This would allow for precise control over our system. As far as electricity goes, we weren't sure how much power we would actually need. After looking through a few forums, we decided upon a 5-volt power source in the form of a portable phone charger. The charger was able to push out a total of 2.4 amps, which worked in our favor as DC motor speed responds better to changes in amperage versus voltage. For our bubble solution, we found that incorporating light corn syrup into a mixture of water and soap, we could make a solution that produced bigger bubbles, as the corn syrup increased the surface tension of the bubbles, making them last longer.
Now that we had collected our ideas through our research, we needed to start drawing up plans for our bubble blower. We decided that we wanted to 3D print the housing for our bubble blower, mainly because it would look cool. This meant that our design would have to be really compact though, due to the restrictions on the size of the objects that can be printed in the makerspaces on campus. We started by drawing out plans for the box that would house the circuitry and motors. Because we were limited to printing a 6-inch cube, it was hard to make everything fit, but we realized that we could fit a shelf inside of the box if we print it with a certain orientation, which would give us a lot more surface area to work with. We also planned to use a CD with holes drilled through as our makeshift bubble wands. Since the CD would be circular, it would rotate really well and be easy to attach to the motor in the center. The fan would be attached to the front of the box and would blow air through the rotating CD attached to a motor. Now that we knew what our original plans for the prototype were, we were ready to start building. The circuit began with a breadboard that had 2 5-volt DC motors attached by an H-bridge and an IR receiver to allow for pulse width modulation. In layman's terms, the different buttons on our IR remote would change the speed at which the motor spun. After a 12-hour 3D print for the box, we started to assemble. Our original idea to use a 3-blade fan didn't turn out as well as we'd hoped. We had to resort to other ideas to generate enough wind power to make our bubbles detach from the CD. We tried everything from cardboard blade fans to 3D printed ones, and nothing seemed to be strong enough. What we eventually noticed from the patents of previous bubble machines was that centrifugal fans allowed for plenty of airflow and a concentrated air stream. So we got to the 3D printers and made it happen.
Our first idea to use the CD did not work. The bubbles dribbled out of the front and never detached from the machine. This prompted us to find another way of making our own bubble wands. We settled on using zip ties. They actually worked pretty well. We faced multiple challenges when it came to producing our bubble machine. Our first idea for our fan did not work because there was no way for the fan to intake air while it was sitting in the front of the closed box, and its airstream was also not enough to blow bubbles out of the wands. Our first wand did not work either because the bubbles would dribble out of the CD rather than detaching. Our first iterations of the bubble solution were also either too thin or too thick for good bubbles to form. Basically, we had a lot of problems that we needed to fix. We decided to fully construct our own fan out of 3D printed parts as an alternative, so we could have a more directed airflow. We fixed the bubble wands through the implementation of zip ties. The solution to our bubble solution was found through further experimentation with different ratios until we found one that worked.
FEDD finally came around and it was time to shine. Luckily, our group had no complications whenever it was our time to present in front of the judges. Everything went smoothly and we had just enough bubble solution to make it through the judging and have a little show and tell afterwards, but we definitely should have made more. Our team placed 3rd out of 10 or more teams. This is due to the fact that our design focused more on the portability rather than altering bubble size, and because we overfilled the bubble reservoir which led to spillage. FEDD seemed like it was very far away at first, but we soon found out how fast our time was running out. Our team definitely could have benefited from starting earlier. Our design had room for improvement when it came to being unique. Our focus was on making the machine portable, but we should have researched more possibilities to alter our design, like changing bubble size. Everyone had conflicting schedules, so it was hard to meet, but we could have sacrificed more to meet more often. Our group's ideas stemmed mainly from patent research and past bubble blower designs. We could have benefited from more professional insights and licensed engineers here on campus. The purpose of this assignment is to combine unique ideas to create something new, so explore designs that will make your project stand out amongst your peers. Try to include everyone during group discussions because you never know what people are thinking. The last couple of days before FEDD are filled with teams meeting everywhere to try to finish their projects, so don't be one of those teams. Your final video presentation will be easier if you have plenty of footage readily available as a resource, so as a general rule, record at least one video every meeting.